cosmic time machine, the Rubin Observatory's epic 10-year sky odyssey. Imagine a telescope so powerful it captures the universe in motion, stitching together 10 years of nightly snapshots into a breathtaking time-lapse movie of the southern sky, revealing the dance of asteroids, the flicker of supernovae, and the subtle warp of dark energy across billions of light-years. This is the promise of the Vera C. Rubin Observatory, formerly known as the Large Synoptic Survey Telescope, LSST, a groundbreaking facility perched on the windswept summit of Cerro Pachon in Chile's Atacama Desert. Officially renamed in 2019 to honor astronomer Vera Rubin, whose work on galaxy rotation curves provided key evidence for dark matter. The observatory represents a $680 million collaboration between the U.S. National Science Foundation, NSF, Department of Energy, DOE, and private donors through the LSST Discovery Alliance. Construction, which began in earnest in 2014 after topping the 2010 Astrophysics Decadal Survey, has transformed a rugged peak 2,700 meters above sea level into a state-of-the-art cosmic sentinel, with its 8.4-meter segmented mirror telescope and the world's largest digital camera, poised to redefine astronomy. As of September 2025, the project nears full operations, with first light images released on June 23, 2025, and commissioning data Preview 1, already yielding discoveries like new asteroids reported to the Minor Planet Center and observations of the interstellar object 3 I/Atlas. This 10-year legacy survey of space and time, LSST, isn't just a survey, it's a dynamic chronicle of the universe's evolution, capturing 20 billion galaxies and 5 million asteroids in unprecedented detail, a time-lapse that will illuminate the cosmos's deepest secrets for generations. The Rubin Observatory's journey began in 2001 as a bold proposal for the LSST, envisioned as a wide-field survey telescope to map transient events and faint objects across the southern hemisphere, complementing space-based missions like Hubble and JWST. Led by the Association of Universities for Research in Astronomy, AEORA, the project secured federal funding in 2014, with private contributions from philanthropists like Charles Simonyi, namesake of the telescope, accelerating construction. Site work on Cerro Pachon started in April 2015, chosen for its exceptional seeing conditions, clear, dry air yielding sub-arcsecond resolution, and proximity to other facilities like Gemini South. By 2020, the primary mirror's 18 segments, each 1.4 meters wide and coated with aluminum and silicon dioxide for 99.9% reflectivity, were polished at the University of Arizona's Mirror Lab, a feat of precision engineering weighing 3.4 tons total. The LSST camera, built at CELAC National Accelerator Laboratory and dubbed the largest digital camera ever for astrophysics, features a 3.2 gigapixel focal plane with 189 charge-coupled devices, CCDs, capable of imaging a 9.6-square-degree field, 40 times the full moon's area, in just 30 seconds. Delays from COVID-19 pushed first light from 2023 to June 2025, but as of September 2025, the observatory has completed on-sky commissioning, with full survey operations slated for late October after a one-month engineering pause. This timeline, adjusted in the project's integrated schedule on September 3, 2025, ensures the telescope's rapid slew-and-shoot cadence, observing 1,000 square degrees nightly, kicks off the decade-long quest to film the universe's unfolding drama. At the core of the Rubin Observatory's magic is the Simonyi Survey Telescope, a revolutionary design blending classical optics with cutting-edge robotics to deliver the LSST's time-lapse masterpiece. The 8.4-meter effective aperture mirror, segmented like the giant Magellan but optimized for speed, tilts via a novel 3-mirror anastigmat system, correcting aberrations across a vast field without a field rotator. Paired with the LSST camera, 64 centimeters wide, cooled to minus 100 degrees Celsius to minimize thermal noise, it captures images in UGRZ filters from ultraviolet, U 320 nanometers, to near-infrared, ZY 1 micrometer, enabling multi-wavelength views of everything from exploding stars to distant quasars. The camera's readout time of 2 seconds and 15-second exposures mean it snaps 1,000 images per night, totaling 15 terabytes of raw data daily, processed into 500 petabytes over 10 years by the data management system at SLAC. This pipeline, using machine learning for transient detection, will alert astronomers worldwide within 60 seconds of events like supernovae, enabling follow-up with telescopes like ESO's VLT. As Vera Rubin herself championed wide-field surveys, the observatory honors her by mapping the missing mass of dark matter through gravitational lensing, while its time-lapse reveals the sky's heartbeat. Asteroids tumbling, galaxies wheeling, and cosmic transients flashing like fireflies in the night. The 10-year legacy survey of space and time, the LSST's flagship program, transforms the Rubin Observatory into a cosmic cinematographer, imaging the entire visible southern sky twice weekly to create a dynamic, high-definition reel of the universe's evolution. Starting late 2025, the survey will cover 18,000 square degrees, twice the sky's surface area, from 30 degrees south to the pole, prioritizing the galactic plane and extragalactic deep fields for depth. Each visit yields paired 30-second exposures in GRI filters, accumulating 825 visits per field over the decade, with UZY filters sampling 225 times for color calibration. This cadence, designed for difference imaging to spot changes, will detect 10 million supernovae, 20 billion galaxies, and 5 million asteroids, including 100,000 near-Earth objects, NEOs, vital for planetary defense. The time-lapse aspect shines in variable phenomena. Kilonovae from neutron star mergers, gamma-ray burst afterglows, and microlensing events probing exoplanets, all time-stamped to millisecond precision. As of September 2025, commissioning data from Data Preview, one has already submitted the first Rubin science paper, Choi et al., 2025, on transient rates, proving the survey's prowess in capturing the universe's pulse before full operations. One of the LSST's crown jewels is its assault on dark energy and dark matter, the invisible architects of cosmic fate, with the time-lapse survey poised to map their influence across 10 billion years of expansion. Vera Rubin's legacy looms large here. Her 1970s rotation curves reveal dark matter's gravitational grip on galaxies, and the Rubin Observatory extends this by weak lensing, subtle distortions of distant light by foreground mass across 20 billion galaxies. Over 10 years, the survey will measure cosmic shear with 1% precision, constraining the equation of state W for dark energy, currently -1 plus 0.05 from DESI 2025 data, potentially revealing if it's a cosmological constant or evolving phantom field. Time domain lensing will track transient alignments, like Einstein rings flickering as lenses move, refining Hubble constant measurements to 0.5% accuracy, resolving the 2025 tension at 5 sigma. Dark matter substructure, Rubin's unseen halos, will emerge in dwarf satellite distributions around the Milky Way, with LSST detecting 10 times more than Gaia, probing cold dark matter's clumpiness and testing alternatives like fuzzy dark matter. Tyson's cosmic indifference fits. These forces don't care about us, but the time-lapse unmasks their silent sway, turning Rubin's intuition into a cinematic revelation. Solar system science gets a front-row seat in the LSST's time-lapse, with the survey acting as a celestial traffic cop for the 1 million-plus asteroids zipping through our neighborhood. Rubin's rapid cadence, every 3-4 nights, will catalog 90% of NEOs larger than 140 meters, flagging potential Earth impactors like Apophis with weeks of warning, per NASA's 2025 Planetary Defense Coordination Office benchmarks. The time-lapse reveals orbital dances, Trojans trailing Jupiter, centaurs blurring comet-asteroid lines, and interstellar interlopers like Oumuamua and 3I/Atlas, whose 2025 observations by Rubin already refined their hyperbolic paths. Phase curve analysis from repeated imaging will classify compositions, icy versus rocky, via color photometry, while light curves spot rotators and tumblers, unlocking formation histories from the Kuiper Belt's fringes. Tyson's asteroid warnings resonate. In September 2025, LSST commissioning spotted 50 new NEOs, including a 100-meter city killer, proving the survey's vigilance turns cosmic roulette into predictable orbits, safeguarding our blue dot. Transient astronomy, the LSST's heartbeat, thrives on the time-lapse's ability to catch the universe's fireworks. Supernovae exploding, novae flaring, and variable stars pulsing, in real-time alerts to global telescopes. Over 10 years, the survey will net 20 million supernovae from type Ia standard candles, calibrating distances to rare type DUN hydrogen-rich blasts probing progenitor winds. Difference imaging, subtracting nightly frames, detects changes to 5 mmAg precision, triggering broker systems like Antares to classify via machine learning with 90% accuracy in 2025 trials. Kilinovi, neutron star smash-ups forging gold, will appear as blue transients fading red, their time-lapse evolution mapping our process nucleosynthesis. Tyson's supernova fascination, stars' cosmic farts seeding life, aligns. LSST's decade-long watch will film 100,000 such events, illuminating stellar deaths and the elements in our veins, a dynamic obituary of the cosmos. The Milky Way's architecture, Rubin's dark matter domain, unfolds in the LSST's time-lapse through proper motion mapping of billions of stars, tracing the galaxy's spiral arms and bar. Gaia's 2025 data release complements Rubin's wide-field depth, but LSST's southern focus resolves the galactic plane's dust-obscured heart, detecting 10 circumflex 9 stars to magnitude 27, revealing variable RR Lyrae as distance markers. Time domain photometry spots Cepheids pulsing every 70 days, refining the distance ladder and Hubble tension, while microlensing surveys toward the bulge probe exoplanets and dark matter clumps. Rubin's halos, inferred from rotation, will manifest in stellar streams like GD1, warped by dark matter substructure, with LSST's 0.2 mass-hour astrometry, over 10 years, resolving their tidal tails. Tyson's galactic wanderings fit. This time-lapse turns our home into a living map. Rubin's unseen mass dancing with stars and cosmic choreography. Data management is the LSST's unsung hero, a petascale pipeline processing 60 petabytes of images into accessible alerts and catalogs, democratizing discovery for thousands of astronomers. The alert production system, tested in 2025's Data Preview 1, streams 1,000 transients nightly via Kafka brokers with 99% uptime, enabling citizen science like Zooniverse's 2025 supernova hunts. The Data Access Center at SLAC, with 20 PB storage, offers Jupyter notebooks for custom queries, while machine learning classifiers, trained on 10 circumflex 6 labeled events, achieve 95% purity for gravitational lenses. Ethical AI ensures bias-free alerts per 2025 NSF guidelines, while open data policies, 80% public within 24 hours, empower global teams, from Chilean students analyzing Magellanic Clouds to Indian coders hunting exomoons. Tyson's open sky ethos shines. This time-lapse isn't elite, it's everyone's, turning data floods into communal waves of wonder. Challenges and legacies cap the Rubin saga, commissioning snags like 2025's mirror alignment tweaks delaying full ops to October. Test resilience, but first light's June 2025 images, resolving Andromeda's arms at 0.5 arcseconds, prove the payoff. Budget overruns, mitigated by private funds, underscore collaboration strength, while indigenous AEURA partnerships with Chile's communities honor local skies. The survey's 10-year arc will redefine cosmology, from dark energy's W, target 2% precision, to 10 circumflex 5 exoplanet candidates via microlensing, seeding missions like Plato, 2030s. Rubin's namesake legacy, Dark Matter's Veil, lifts through lensing maps of 10 circumflex 9 galaxies, probing Einstein's gravity at cosmic scales. Tyson's cosmic call resonates. This time-lapse isn't just data, it's destiny, filming the universe's story so we can write the next chapter. The Rubin Observatory's 10-year time-lapse isn't a telescope's whim, it's a symphony of light and legacy, Vera's vision realized in pixels and purpose. From asteroid sentinels to supernova symphonies, it captures the southern sky's secrets, a cosmic reel for humanity's gaze. As ops launch in October 2025, expect alerts to flood the ether, birthing papers, probes, and perhaps paradigms. Tyson's stars align. In this indifferent cosmos, Rubin's lens reminds us, we're the observers, and the show is ours to savor.